Is 3D printing the future of construction? Join us as we discuss this and more on 3D Print the Future with your host, Frank Awesome.
Hello, and welcome to the show. Have you heard 3D printed construction is here? And if you ask me, it is here to stay. Of course, we have a lot of hurdles to jump, but the good news is companies around the world are working every day to bring this tech to the mainstream market. On 3D Print the Future, we give our listeners firsthand experiences shared by industry experts and business owners. We'll discuss the incredible things that are being done now and where this technology could possibly take us in the future. On today's episode, hailing from my own hometown of Calgary, Alberta, our guest is a T-shaped engineer who is also an expert generalist. He's passionate about design, artificial intelligence, and machine learning, as well as 3D printing and additive manufacturing. He's completed a PhD in the UK at the University of Nottingham in metal additive manufacturing and has been a finalist and a back-to-back winner in several international design competitions for additive manufacturing. Currently working at Exergy Solutions in Calgary with their metal 3D printer, please welcome to the show, Cassidy Silbernagel. Did I say that right, Cassidy?
It's Silbernagel.
Silbernagel? I was close. So
yeah, it's really close.
Either way, how are things going today?
Pretty good. Yeah, things are really good.
Good to hear. I've been looking forward to having this chat with you because you do kind of get into the not just designing weird things. You're really getting into some very unique engineering, some parts, and getting into metal fab too, which is really, really cool. But to start things off, from what I know about you so far, your whole career, you've kind of been challenging a few of the less scrutinized aspects of designing for additive manufacturing. So tell us about some of those experiences and what things are you looking at that we can maybe do better or more of?
Yeah, sure. So I think my focus with additive manufacturing has always stemmed from trying to push the envelope of what we think we can do with design. So I really like kind of breaking components and pieces and machines down to their basic fundamental functions, like first principles. And then what we're able to do is build it up with a blank slate while still trying to achieve those functions, those core functionalities. And while you're doing that, you're able to incorporate a lot more functionality into the part that you couldn't really do if you just said, okay, here's a widget, redesign this for additive. I like looking at, okay, what does this widget do? How does it interface with, the components around it? How do you interact with it? And then trying to go from first principles, building that back up. So you still get the same thing, but then, what if we can do integrated cooling, or if we can do wire passages, or what if we can, reduce some weight, or how about combine these multiple pieces together and see what we get out of this. So I've really wanted to do that. And so I started out my career as just a mechanical design engineer, and I found kind of the limitations of traditional machining with CNC machines and lathes, and I wanted to do more organic shapes, things that you couldn't really do, or if you did do them, you'd have to have really complicated jigs or multiple fixtures and setups, and I was really drawn to additive early on. So I've been working with additive probably for about 10 years now.
Wow.
And, I started out, this was 2010. I was looking around, I saw on, all these websites, people are doing this plastic 3D printing, but everyone's doing plastic. So I want to do something else. I saw some posts at the University of Washington. They were doing some binder jetting. So they were coming up with custom formulations for the binders and the powders. And I thought, you know what, I'd like to do that because everyone's doing plastic. It's 2010. Everyone has their own hobbyist printer. So.
What's funny about that is that plastic wasn't the first thing that was 3D printed, though. It was metals.
Well,
SLS printing metals in the car. The car manufacturers were doing prototype parts using SLS, using metal powder. And this was being done in the 80s, 85, 80, in the late 80s, they were doing this.
Yeah, when you think about what additive is, I mean, you can even go back even further than that. So people were experimenting in the early 1900s with different welding techniques, and they were building up layers of metal to create propellers and things like this. So
That's 3D
when you
printing.
really, yeah, it was 3D printing before anyone knew it, but it was layered welding, or I can't remember. I came up on this bit of research or a bit of knowledge when I was doing my research for my PhD. And, when you look at what Additive's been doing, they always credit it to, I forget his name right now, but he was developing SLA, Carl Decker, I think, maybe, don't quote me on that one.
I know I've read the name, but I don't even think I'd recognize it if you said it.
Yeah, so I mean, it goes back to those early days. He was the founder of 3D Systems because they came up with the photo activated resin that you could 3D print, and that was kind of the start of what rapid prototyping or additive manufacturing really was. But yeah, it's kind of really taken off, and so I really got interested in this hobbyist kind of space. Started tinkering on my own. Company I was engineering, doing some engineering consulting with, they got an old large format Stratasys machine, and it was completely dead. So they're like, hey, you're into 3D printing, let's see what you can do with this. And so I had to kind of rebuild a lot of the components, source some parts that weren't even available anymore, and basically got it up and running.
That would be a ridiculous amount of fun.
Yeah, it was a fun days. I mean, you didn't know what you could do.
Wow, what a fun day that would be.
Yeah, it was. It was a few years that I got to play with these things. So
wow, cool.
Yeah, and then once we were working with that, we were able to, what can we do with this 3D printing plastic stuff? We were printing in ABS, and we did a lot of different things. So we created some molds for some wax casting that we were going to do some lost wax stuff. We created some patterns for sand casting that we sent down to a foundry, and they used those to do some rapid prototyping castings for us.
Okay.
And then rapidly testing different iterations of form and function. So we were doing some work with airflow and fuel mixing. And so we were able to rapidly prototype a bunch of different iterations, in the space of just a few days. And it was really interesting, but I really wanted to focus more on, okay, like this plastics is fun, but let's, real machines are made out of metal. So what can I do with metal? And that's kind of what led me down the path and looking into doing the PhD in England.
I think the best use of 3D printing is to do things like that with materials that we've always known how to build with, but we've always had to mold these things, pour them into molds and things like that. But what 3D printing really does for us in these things, even for metal manufacturing, is that you can print impossible structures within structures that you never could mold if there's just no physical way to mold for this sort of thing. And in my mind, I'm seeing that the extruder assembly you were doing for the Ultimaker Plus. Am I getting that right?
Yeah, the Ultimaker 2 Plus, yeah.
Has these internal structures to it that you could never, ever mold that.
Yeah, that's kind of what I found, like my PhD, what I really wanted to do. I have a lot of experience in the past with electric motors and generators. And so my PhD was initially looking at what can additive do to, kind of improve this mechanism, this electromagnetic mover, really. And
you printed you're printing two different kinds of metals in one piece. Am I right?
No, so I really wanted to, but the technology isn't quite there. So I was printing some aluminum alloys and pure copper. So it's, I found out, my goal with the PhD, I wanted to 3D print this multi-material electric motor and have it run, and it'd be so amazing. But the reality of it is that, these materials that we're 3D printing with haven't even had some of the basic properties characterized properly. So for me, I couldn't even tell you what the electrical properties were or what the characteristics were with it being 3D printed in different orientations, different heat treatments. And that was kind of where my PhD focused, was doing this basic electrical characterization of these metals that were 3D printed with respect to orientation and heat treatment. And once I got that, then if you have these materials, what can you do from a design standpoint to enable the future of electric motor design with additive?
So what are you seeing for as uses for, like, what industries do you think will really adopt a metal 3D printing, where it can, do you think it'll just be used for prototyping, or do you think they'll start using 3D printing metals for mass production?
Well, they are doing mass production with certain areas. So with metal, I mean, you can really do anything. And some of the freedoms you're able to achieve is you're able to manipulate the structures in the entire part. So for instance, GE, they were looking at how can we improve our fuel nozzles in our jets. And so they took a look and they saw, you know, we have this freedom of geometry with metal 3D printing. Let's do something with our fuel nozzles. And so they look at, you know, if you Google it, you'll see this nice, beautiful assembly that's, you know, amazing. But the reality is that it's just a small little disc at the very end, and it's the fuel nozzle tip that's 3D printed. The rest of it is a fancy casting. But
Okay.
because they're able to 3D print just this one tip, they're able to increase their fuel burning efficiency by, I can't remember, it's 10, 15, something like that %, which in turn saves them a lot of money. It reduces greenhouse gases, and it showed such promise that they didn't just, you know, ask someone to build these things. They didn't even just go and buy a machine. They bought 2 different companies that they could leverage to build these things.
Really?
So they're building thousands of these every year, and they're currently flying up in the air. So there's metal parts on spacecraft and satellites that are going up into space. So companies like SpaceX are developing their rocket housings. They're the Bell housing out of 3D printed materials, usually copper alloys, because you're able to finely tune where the cooling is. So you can customize the shape.
You're
but
talking
you can
about the
also,
internal tanks.
so where the fire comes out, basically.
Gotcha. Okay. Yeah.
And so they're able to cool those so precisely because they're 3D printing the cooling channels directly into the part. And with satellites, I mean, it's something on the order of $10,000 a kilogram to put it up into space. And so every kilogram matters, shaving that weight off. And so they're building these brackets that are organic looking structures because they know what the forces are going to be on these satellites, so they can basically do a finite element analysis on this block. They know what the interfaces are, and then the computer does an iterative design where it calculates the forces and removes the material automatically. So it only puts the material where you need it. And that process is called topology optimization. You're optimizing.
Makes perfect sense. Yeah. You
Yeah.
don't need material where there is no force. So there's,
and so they're putting these things up into satellites as we speak.
Yeah. And that's how he minimizes things, like that's how he gets so many up there. He builds things in that way that maximizes the space and minimizes weight, which is what space travel is all about.
Mm-hmm.
But we're talking about 3D printing here. So I just kind of wonder, what kind of services do you see this metal 3D print? It's fascinating to me that metal 3D printing started so long ago, and they still, they're only now just working out how much better it is.
Mm-hmm.
So you're talking about like just high end products like that, or we're going to see stuff like that on the market, 3D printed objects?
So it really depends on
carburetors,
the functionality. So
anything like that.
There's a combination. So I've wanted to try to kind of get people to think differently about how they approach design. So when I was doing my PhD, I got a little bored, wasn't doing enough design work, so I entered a few 3D printing competitions. And the first year I entered, you know, I saw that the deadline was extended. I had a free weekend, so I threw something together over, Saturday, Sunday, submitted it, and ended up winning the competition.
What was it?
So it was a redesigned electric motor casing. So this
So
casing was something that I had worked on in the past, but we had retrofitted something and it didn't really work really great, but it did the job. And I thought, what if I could 3D print something that was perfect for this? What would it look like?
mhm.
And so I made it so that it could accept all the main components of the electric motor. So you wouldn't have to really change anything. You just take it as is and put a different casing on. But this casing had internal cooling channels. It had smoothed out wire passages so that you could, route the wires without worrying about, sharp corners cutting the insulation. I did some topology optimization to remove the weight from where it wasn't needed, and just made everything really thin shells so that you only had mass where you really needed it.
Interesting.
And that ended up winning. And the next year, so when I won, it was the student category because I was doing my PhD as a student. But the winner of the professional category had designed this satellite mounting system, which had a movable kind of ball in the top. It was like a socket, and as you tightened up this ball was built in like 3 sections. And as you tightened it, it had a wedge in the middle. So as you tightened it, the ball kind of expanded a little bit, which locked it into place.
Mm-hmm.
And as you loosened it, the ball would retract, and then it could swivel in its socket. And I really like that concept of having moving parts that you couldn't really build in a 3D print. And so I wanted to do something with that for my next design. I looked at I was really fascinated by some fluid flow, and I thought, moving parts, fluid flow, something that could really be in need of a redesign. And I came up with this carburetor design. So this carburetor, I looked at a carburetor which has hundreds of different parts when you include all the fasteners and springs and the bits and pieces that are in there. And I thought, what can I do to simplify that to as simple a piece as possible? And so I came up with a design that I think it had 5 pieces altogether, but all those 5 pieces were printed in the same STL. And so those pieces,
but still 5 separate parts.
There's 5 separate shells. So 4 of those shells, like one was a plate that could be attached on, but 3 of those, one was a spinning throttle plate, one was an inlet choke plate which pivoted, and the third one was a float, which was a hinge mechanism which was able to move in and out. And so those were all printed in place, so they had enough clearance so that they could move freely, but you couldn't physically put them in or take them out. They were designed as one piece, and they were also designed to have minimal support structures so that you could build it without having to support the entire thing, so that these pieces could still freely move.
So were the top tolerances, tight enough for it to work properly? Like, how are the surfaces? Because when you print on a 3D printer here, your surface is never smooth in reality.
Yep.
No matter how good your print might be, your surface really never is smooth. So how does that affect the workability of a part like that needs to be, basically high tolerance, right?
Mm-hmm. So you have to kind of rethink, why does it need to be high tolerance? So for the spinning bit, you generally want this high tolerance so you can get a really nice press fit for a bearing, because the bearing surfaces are really high precision. But for this, there's some tricks that people have used with using O-rings. So the O-ring is able to squish the outside surface of the bearing to hold it in place. And it's a trick that's used when you have large thermal differences in the expansion of the material. So if you're putting a steel bearing in an aluminum housing, that aluminum's going to expand a lot more than the steel. And so to take up the slack, if you don't have enough press between the materials, they insert a an O-ring in there to kind of keep the pressure on the outer surface, the outer race of the bearing, so it doesn't spin, but this inner shaft can still spin. And so I designed the bearing interface to put 2 of these O-rings in, so you can put the bearing in there so that the throttle plate will still be able to spin with the bearing, but the surface finish isn't as critical because you have these O-rings that are able to make up the difference.
Oh, that is super interesting. I want to kind of go back to your to you developing these hot ends for machines, because I want to kind of steer this conversation a little bit towards 3D printing construction, because that's kind of what I'm all about, and that's really the information that I really want to get out there. What sort of how can I say this? Do you have you looked into what they're using right now for like 3D construction printers, the sort of nozzles that they're using, and the sort of things that especially Apicore side, you can really see the nozzles that they're using there. They take a lot of pictures of that stuff. What's your opinion on that? Do you think they're going the right direction, or do you kind of see that and think to yourself there's room here for improvement? What's your opinion on that?
Yeah, so it's I've looked at a few different 3D printing construction things. There are some companies there that do keep all of that very secret, and so it's hard to say. There's one thing where you're able to, you have an idea, let's see what's out there to execute this idea as quickly as possible. And so you find off-the-shelf components, and you kind of live with the compromises that come with getting something that's off the shelf for your customized application. But once you get to the point where you know what you need it to do, and the off-shelf component isn't doing what you need it to do, there's an opportunity to go back and try to redesign to get the characteristics out that you're needing to. And so that's kind of something that I think design really opens up when you're using additive manufacturing, because like I was saying before, you can go back to those first principles and say, what does this thing have to do? What are the minimum requirements to achieve that? How can we, build something around those principles and get it to do what we want it to do? So I just found out yesterday that I was a winner in another design competition.
You just found it out yesterday?
Yeah.
Oh,
so
congratulations.
Thanks. Yeah, thanks so much. The finalists were announced. I was a finalist a month ago, and then the winners were announced just yesterday. So, but some of the other winners in this were in the construction area. So there were 2 different companies that were doing kind of like the concrete extrusion, and one of them was a really interesting application. They were building bricks. Like, it was just traditional bricklaying. You have a guy, he's laying bricks, he's laying the mortar, he's tapping it and adjusting it. But what they've done is they've incorporated augmented reality. So there's someone else beside him with a camera taking a picture, and they're able to micro adjust these individual bricks. And then when you zoom out on the whole, it's this fantastic 3D designed like pattern that you would never be able to achieve without this like extra tool that can help guide you along the way.
You're still that is really cool, but I don't know. I've seen those bricklayers, and they're really, really neat, but you're still limited by a brick.
Yep.
The same way you're
absolutely
limited by a 2x4. And I've said this to many people, and I'll say it to you too. A brick is always going to be a brick. You can't engineer a brick to be anything but a brick, and you can't engineer a 2x4 to be anything but a 2x4. But when you're talking about 3D printing and you're talking about extrusion of a material, right from the development of that material to how it lays down to how it cures, you can engineer that entire process to do whatever you want to. Now, if you're developing hot ends and things like nozzles, I think there is a huge opportunity in, companies like ours and other companies will want people out there that have designed nozzles or sets of nozzles, for example, that can lay down the material in really specific ways. So for example, Apicore has this little bar that just flips down when it goes to an outside wall. Little bar flips down, it scrapes up the wall and it makes it more or less flat. But my thinking is that you could probably engineer a nozzle design that does that without needing to have all these extra parts on.
Yeah.
So going back to what you like to do is take things and say, okay, well, what's the minimum of what we need to get this done? So I need a nice straight wall with very little to no gaps. So Apicore says, well, we'll just put a little arm on there and swing it over and have it go across. Brilliant. But there's a lot of little moving parts in there and little screws, and you need a little hose with a little bit of water going down so it helps smooth it out. And it just seems like something that's going to break a lot.
Mm-hmm.
But if you could design nozzles that do the job for you, and it's a one piece, no moving parts, then you're golden. I think somebody like you would be, people like you would be perfect for that sort of thing, because you're already looking at ways to do that for the hobby industry, basically.
Mm-hmm.
Just scale that stuff up.
Yeah.
And that's what really interested me. But when I look at your stuff, I don't always see, the really amazing things that you're doing in small scale. I see what you're doing, but I see it in large scale. I see how easy it is for you to scale up your stuff. Where do you see yourself going with all of this? With all this skill and all this talent, you really seem to know what you're doing. I saw the stuff that you've done. It's beautiful, beautiful work. Where are you going to go with all this?
So I think what I want to do is I really want to take these ideas and bring them to industry so that we can really start, changing the world. I think there's a lot of room for improvement in terms of, our overall footprints, our greenhouse gas emissions. And we need to kind of work incrementally to try to build this better future. And so being in Calgary, we're in the heart of, oil and gas country. And there's a lot of inefficiencies when it comes to oil and gas production and exploration and refinement. And so, that's one of the things that I'm really excited for with where I'm working at right now is with Exergy Solutions. They have a lot of really good ties with the oil and gas industry, and their clients are really open and receptive to additive manufacturing. And so it opens up a door to really introduce things that can really, help improve those that kind of production and refinement and exploration, while at the same time, we can also develop other technologies that can help us, move away from oil and gas. We can't just transition overnight. We have to keep on going with the way what we have been going, while also transitioning to this new future. And so while we're transitioning, let's make both of them more efficient and better for the environment, for everyday people, really.
I think we'll always use oil and gas. I think oil and gas isn't going to be something that we're going to so-called abolish.
Yeah, exactly.
I just think it's really important for us to stop relying on it, especially for a means of energy, as a means of manufacturing is one thing. And I think that's sustainable. But as a means of energy, just burning it, burning your natural resources, burning natural resources to get natural resources, and then burning some of those natural resources to refine the natural resources so that we can then burn those refined natural. We're just burning things all day long. And that's the part that we need to really get rid of.
Yeah, we're always going to need oil and gas. I mean, there's always going to be methods of transportation that we can't electrify. And so we'll need these highly dense energy sources like petroleum products to do some of the things that we can't do otherwise.
So what kind of things are you going to do for them? What sort of parts? Obviously you're not going to 3D print a bunch of trucks for them or wellheads or anything like that. But so what sort of applications oil and gas? What sort of applications there would you be working with?
Yeah, it's kind of a tricky situation because there's a lot of competition in this area right now, and so basically we're trying to follow the model that the aerospace industry has followed, where I kind of see it. There's kind of like 4 different levels of design for additive manufacturing, and right now oil and gas is kind of in phase 1 and phase 2. So phase 1 is you literally have part X. And you want to make that exact same part using additive manufacturing. In some cases, that doesn't make sense because additive is more expensive, especially if that part has been optimized for traditional manufacturing. But there are instances where additive is the only and the best way to go. So if it's a really expensive material that it's difficult to machine, but yet it's able to be machined or manufactured using additives such as, Inconels and titaniums, then it makes sense to go with additive even without changing geometry. For parts that are, extremely long lead times, so some castings or forgings, with a 6 to 8 month lead time, you can kick it over to additive manufacturing and get it within a matter of weeks. Cases where you have legacy parts, so where the traditional manufacturing chain doesn't make this anymore, you can take that exact same part, send it over additive, and you can directly replace it. So the stage one has its place, has its function, and that's kind of where oil and gas is looking right now. Stage two is also where they're starting to look, where you're taking that exact same part, but you're now thinking, okay, how can I make this better using, additive? So let's do some topology optimization. Let's, get rid of overhangs and introduce 45-degree angles. Let's, see if we can maybe add a little bit more functionality from it, but you're still just kind of taking that same part so that if it fails additively, you still have the backup part that you can throw in there and minimize downtime. So you're still kind of minimizing your risk having this direct replacement. The third stage is where you start taking a step back and looking a bit further back and looking at, okay, well, this part interfaces with this part over here and this part over here. It requires these fasteners, or it requires welding. What if we just kind of took it all and made it in additive? And so you're able to minimize kind of your inventory because you're getting rid of some of these extra parts. You're minimizing some of your post-processing in terms of, additional welding steps. And you can also decrease weight, add performance, and maybe get a bit more out of it. So that GE fuel nozzle, that's kind of like that level 3.
Gotcha.
And then you have level 4, which is you're going back to first principles and you're completely redesigning the thing from scratch to achieve the same goal. And that's where additive provides the biggest benefits, because you can completely reimagine how you do something. So when you're going into oil and gas, we're still looking at that stage 1, stage 2, hopefully stage 3, maybe stage 4, once a company really gets comfortable with the whole additive process. So it is really a journey along to move, industries and companies along this, but the real benefits come with that fourth complete redesign stage.
Of course. And, and even and it's still being proven. Even the hobby printing stuff, there's new motors, new extruders, new machines coming out every day. They're still improving on it. Do you think that there's any room in oil and gas in that industry for 3D printed construction? Because we're really focused on housing, and you see just about everybody who's doing 3D printed construction, we're all just focused on housing, because that's one of the biggest crises that this world is facing right now, and as a whole, at any rate. And so we're really seeing that as a solution, but maybe we're a little bit more blind to some other opportunities. Do you think there are any in the oil and gas industry?
It's hard to say. I mean, I haven't really. This is the first time I've really worked in the oil and gas industry. So I've not really
talk about it like you've been in it forever.
Well, I that's that whole part of being an expert generalist.
Gotcha.
I can learn something very quickly, and that whole T-shaped thing. I have a really broad range of experience that I can draw from.
I wanted you to describe I wanted you to clarify that T-shaped.
Yeah,
I've never heard the term before. I don't know why, but maybe because I'm not T-shaped. I don't know if I am or not. But
yeah,
explain that to me.
Yeah. So a T-shaped person, basically, you are able to pull from a wide range of experiences. So for myself, I've done electrical engineering, I've done software engineering, I've done manufacturing, I've done mechanical. I've pull from some of my old jobs that I've worked in, pest control, carpet cleaning, bakery. I'm a musician. I've, edited and made movies. I compose music, so there's a wide range of skill sets that I have, but then I have this really deep knowledge and understanding in design and additive manufacturing. And
That's awesome. I'm going to start calling
I,
myself that.
yeah,
'Cause I'm a lot like that. I've had a lot of, jack of all trades, and I've got a good understanding of each one.
yeah.
I pull from a lot of different experiences.
The
Yeah, that's
T-shape,
awesome.
yeah. The
Love it.
T-shape takes the jack of all trades,
T-shape.
but then you add in the foundational expertise. So you're an
Mhm.
expert in this one thing, so you can dive really deep in that one topic. So that's what makes someone a T-shaped
That's
engineer.
awesome.
So
Because for me, I'm a designer. That's my base, and I use
mhm.
my experiences, all these different jobs and things that I've done, to I pull from that. That's really.
Yeah,
I'm just super impressed by that term.
yeah, no, it's a term that's come out of California, Silicon Valley,
Okay.
that sort of that
Hmm.
terminology, because it seems like most engineers, or like the stereotypical engineer, I should say, is very I-shaped. You know, this is their stream. They stay in their lane, and you know, if you ask them about this thing over here, they don't know.
They're
You know, so
specialists.
yeah, they're
They
extreme specialists, and you know, they're like that knife where you need to cut through this one thing. That's what you get that person for.
okay.
um, but
I like
sometimes you
that a
just
lot.
don't know what you need,
Hmm.
and so you know, you have these expert generalists as well. So an expert generalist is, you know, kind of the jack of all trades, but you're able to go a lot deeper than just like a superficial understanding of it. And so, you know, when I talk about software engineering or the energy sector, or you know, wind turbines or computer programming or any of these things I've talked about, I have a really deep understanding of each one of those that I'm able to draw from. So it's not just like, oh yeah, I once made this one thing. You know, I've dove in deep into each one of those things, and so I can draw from that experience.
No, I totally get that, man. It makes more sense than I've heard anybody make sense in a long time. And you mentioned that you do follow, some of the concrete printing companies, Apicor and all those guys. What do you think about where they're at right now? And if you decided to get into the business, which one would you contact and why?
So I I wish I had more in-depth knowledge of that industry. I can't
Testing
speak
you a little bit,
to,
yeah.
yeah, I can't speak that deeply to it.
Okay,
But
fair
I
enough.
think I think what really needs to occur is real results. So there's, you know, have you ever heard of the hype cycle?
No.
So the hype cycle is a basically it's a path which a technology follows, where early on you start out where, you know, it's just academics that are kind of playing in this field, no one really knows about it. But as it becomes, you know, more knowledgeable, then the media starts picking it up, and this peak starts to happen until
That's
you
kind of
reach a
where we're
point
at.
where there's completely unrealistic expectations, and then it drops down into the trough of disillusionment, where people think, you know, the reality and what is promised completely can never happen. And then you have this slope of enlightenment, I think it's called, where basically
I love it.
the general understanding of what these things are and what they can achieve kind of meet back up to what they are able to do. And so 3D printing has gone through this hype cycle, and it's kind of, you know, in this trough where we're now able to play without all these media expectations, and really get real results. The concrete printing, I think, is still near the top
Yeah,
there
we're
because,
definitely not quite peaked the top, or we're just,
yeah,
we're
because
getting some media attention, but it's very tongue in cheek.
Yeah, because there's been so many claims of, oh, this house was printed in 24 hours, and this house was printed in 24 hours, you know, and the amount of news things that you've seen of, you know, houses printed in 24 hours, just it's making people feel like, you know, it's not really reality. And so there's a need to really, you know, show what it can do and show the realistic timeframes. And so there's more and more companies that are starting to do that. You know, like this 3D printed building in the Middle East,
In
where
Dubai
they
there,
said
yeah.
it was,
That was
yeah, you know,
Epicor,
it
yeah.
was is built in just, you know, this short amount of time. But then they don't say it also took them a year to do all the finishing touches to put it together.
No, they didn't
Um,
though. I know that project quite well. I follow them really well. All these companies, that project really was done in just a few weeks, including finished, and they were able to move in, which is why it was so special. A big part of why that building was so special wasn't necessarily because it was finished so quickly, but because it was the first 3D printed building that was going to be used by people, not lived in, but it's an office. And the biggest accomplishment was they put a second floor on it.
Mm-hmm.
And now the second floor was 3D printed and laid in there in a special way. So it does sound really, and your reaction is actually pretty common, where it does sound really fantastic. Like, what, 24 to 48 hours to print house, really? And then people are like, oh, well, you're going to spend all this time, developing the property, and then, oh, you got to spend all this time, finishing the houses. Well, let's look at, air flight times. It takes me 20 minutes to travel from here to another place, but they don't say that it takes me a half an hour to get to the terminal, and then another 45 minutes to get through the gate, and then another hour to get to the plane, and then a half an hour sitting on the plane. It's not a 20-minute trip, it's a 3-hour trip.
Yeah.
So it's kind of the same thing where we're making analogies based on the actual print time of the building. And you're right in saying, well, there's time spent before that, and there's time spent after that. But where I think people don't realize is that you don't spend any more or less time on the finishing or starting than you would on a normal brick and mortar building.
Yep.
The time is saved in how long it really, and that's why we use that time, because that's where the time is saved. And think about this, even if it takes, I'm going to go way out, even if it takes 2 weeks to print and finish a small home, we're talking like, 750, 800 square foot, small house on a back lot somewhere. Say it takes you 2 weeks to do that. It would have taken you 18 months to build that out of brick and mortar.
Yeah, absolutely.
The enormous savings in time, it makes that other stuff kind of go, meh,
Yeah.
Now it's not that big a deal. But you're right. We don't put that in the time it takes to build the house. So yeah, we were printing for 4 days, but it took us a month and a half, 2 months from yes, we dig the ground to go ahead and move in. It's not really a 24-hour process. So you're absolutely right about that.
I think the promise, though, is being able to, work and then start finishing some of these things. So putting in the places where you're going to put the electrical and the plumbing and, the doors and the windows and the outlets, being able to work so that you can, as you're going, exactly what the layout is going to be. You're not going to guess, oh, I think I want an outlet here, so let's cut a hole. Oh, I guess the 2x4 is over here, so I guess we'll have to cut it over here. And
well, it's all computer generated. It's computer modeled. You're building it with a precise sequence of events, and the workers are following that on their iPads and their computers. They're following the process, and they're monitoring the process, and they're doing what the process tells them needs to be done right now.
Exactly.
Every second there's another process that needs to be done. If they need to put in some supports, the tablet tells them at this point, machine stop machine, add that, restart, and off you go. And they're doing that right now. That's how AppyCore does it. And IB2.
Yeah. So it's kind of an amazing ability. And going back to your question earlier about opportunities within oil and gas and this technology. I mean, we're finding that there are places that are getting less accessible, so being able to find, be able to put down pads quickly, might be a really beneficial thing, because all of a sudden, the melt is happening later, so ground is softening, or, like climate is changing to the point where the time frames that you use traditionally might not able to be followed, and so you may need to have a quick turnaround, like we have an opening, let's go in and do this. That traditional concrete pouring might not be able to keep up with these flexible schedules. So there could be opportunities there. I mean,
absolutely. That actually brings me to an idea we had that I thought was previously unrelated. We want to help with Indigenous communities. We see a lot of Indigenous communities up, especially Northwest Territories, where there's no resources or help for a number of reasons why they are unable to maintain their towns and their townships and their homes. The buildings are ramshackle when they go up to begin with, and then after 50 years of use, you can imagine what that must look like.
Mm-hmm.
And a big problem is the tundra. building on the tundra. It moves. And the problem with wood is it moves with it. It doesn't let it, the tundra slide under it. So our idea is to have topographical maps of an area we plan to print on that perfectly maps the ground, so that we can print our pads in place without having to dig. Print our pads in place so that it understands the gradients, just like auto leveling your printer. We auto level on the ground and then print on that, so that as the earth moves, it slides underneath the building rather than pulling the building along with it. We don't know exactly how we're going to accomplish this yet, but it's something we know is possible. Physically, it's possible. Physics says we can do it. So that's actually one of our plans. So going back to this oil and gas thing, like that's, you're talking about putting up emergency buildings almost.
Yeah, or temporary shelters
and things like that, where you can just go in without needing trucks and graders and dump trucks and a whole big crew. You could send in a guy with a truck and a trailer with a 3D printer, his crew of 3 people, and have your pads printed for your ATCO buildings. Print a dozen or more a day in a day, and then get the hell out of there. And instead of you having to plan for 3 weeks and then do construction for another 2 weeks, you're done in 2 days.
Yeah, exactly.
That's interesting. I'm going to have to go to my team and talk to them about that a little bit as another opportunity, because that's what it's about right now. Looking for, and that's why I ask you about that. Looking for those opportunities, not just trying to, we're not just trying to build a 3D company ourselves. We really want to find where this technology is going to help the most. Part of the onus for doing this show, I really want to find out where this technology can help the most. How can we move humanity forward in the most efficient way? It's all fun and games to make little motors and to make little toys, and I make models and stuff. But how, like you're saying, and I love that attitude, how do we move this humanity forward? And to do that, we need to sort of, go back and look at what the problems are and rethink how we deal with that stuff.
Yeah. I mean, a lot of my spare time is just spent just thinking and pondering kind of these bigger questions and figuring out, how can I make a small change here that can make a really big impact later on. And so, right now with kind of the PhD and with some of these competitions, I found, I'm hoping that I'm just inspiring, getting people to think a little differently about design and what they can achieve, so that, then within their little sphere of influence, they can do their bit, and together we can all kind of make a big impact. It's kind of
Absolutely.
like the whole, COVID thing that we're going through right now, how our countries and how our communities are going to overcome this really comes down to individual choices. Am I going to wear a mask or not? Am I going to adhere to the, the 2 meter distancing? Am I going to adhere to the recommendations of, how many people are in a group? Those individual choices really determine our larger outcome when it comes to this pandemic. And I feel that with, engineering design, my little contribution isn't going to do much, but if it can help inspire other people and they can do more together, we can do a lot more than just what we do individually.
Oh, I agree entirely. We got to all kind of do it together. We're really, a lot of our work is actually spent not in R&D. Most of our work is actually spent in Parliament with our MPs and in government. We have a guy in Ottawa who does nothing but go to Parliament and say, and argue for 3D printed construction, because we figure if we can make it legal I use the term legal, that's probably not the right term for it, but if we make it viable, if we get everybody on our side to do this, our company of course benefits, but the industry benefits from it. And I think that's where the focus has to be, is not on individual accomplishments or what individual companies are doing, but what the industry on a whole is doing, and make sure that we all really support each other and do whatever we can to support each other, because we're all going to win from that. And what I don't see a lot of companies doing is going for advocacy. We don't see a lot of that. We see a lot of development for machinery and materials. So for us, we decided that was going to be our niche. We want to further the human race. We want to help homeless. We want to help veterans. We want to help with the housing crisis. And the way to do that, we thought, isn't to just build a machine and start printing. It's to convince the governments that it's the right thing to do.
Yeah.
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 So to finish things off, I want to ask you what I ask everybody kind of thing, and is that where do you see the industry in general, concrete 3D printing, or even, what you're into? Where do you see it in 100 years, even 500 or 1,000 years? Once the technology, once we've gone over these curves and a few more curves, like you were describing, what happens when it's all kosher? Does it take over everything, or does it become integrated into our way of life?
I think there's it's kind of like cyclical. I see, like we as humans, we started out our little tribes in caves, and then we built our own homes. And I think going back into nature is kind of where we're kind of heading, because we need to find kind of that balance, that I think as Europeans coming to North and South America and seeing people who lived much simply, they lived within their means, they lived according to what the land gave them, and they only took what they needed, whereas the European mentality seemed to be, nature is below us, we can do whatever we want. But I think there needs to be a better balance between ourselves and nature. And so going into the future, I think of some sci-fi novels that I've read, the Broken Earth trilogy. In that society, basically their society completely broken down to the point where they had this ancient technology that they didn't even know how to use anymore, and their buildings were living and organic. And so it was something that they lived in harmony with, that provided them kind of like their filtration and their fresh air, and it built all around them. But then society had evolved back into kind of like a tribalism sort of thing. And so I think trying to find a balance between, how we live our lives and how we choose to live in nature is going to be an interesting balance. And I think, printing with concrete, it's kind of bringing us back into materials that we're used to, like when we touch something that's kind of rough, we like to touch it, like sandstone. It's something that you enjoy, that tactile sensation.
Feels natural. It feels
natural. Absolutely. And so, I think there's elements that we need to try to incorporate back into our homes, like surrounding ourselves with these straight walls that come at 90-degree corners that are made out of these chemicals that off gas for years and years. It was fun, economically when it was,
it was the right thing to do at the time.
It
was the right thing to do with the materials we had at the time. And now
exactly,
we have to do the same thing.
Yeah.
Continue building with the better materials that we have, and then the wisdom that we've learned. I love that. I love that vision for the future. So I think, that's a really good note. That's a really good place to end the show today, just with that really nice positive outlook on how we see the way the world wants to be. I want to thank you, Cassidy, for being on the show today. This was just a phenomenally interesting conversation.
Thanks so
I'm going
much.
to have you back again, and we'll have to talk
All right.
a little bit more about things once you've done a few more projects. I will be watching your projects closely. You can bet that.
Yeah, you bet. Sounds great.
For everybody else, thanks very much for listening to the show. Don't forget to catch the next one, and the one before this, and the one after that, of course. Don't forget, if you're watching this on YouTube, hit subscribe, hit the bell. We love it when you guys do that. Follow me on podcasts, follow us on Facebook, all that good stuff. Thanks everybody for listening and watching. We will see you all next time.
3D Print the Future is sponsored by 3DPHC. Find them on the web at www.3dprintedhomescorporation.com.